brief tutorial will demonstrate how to access elevation data through the NOAA Digital Coast Data Access Viewer for the purpose of creating model grids. First thing you'll need to do is open up a web browser, type in NOAA Digital Coast Data Access Viewer, and it should be the first link here at the top. Select that. You've got three options here. You can search for imagery, land cover data, and or elevation LiDAR data. So we're going to pick the elevation LiDAR data, but don't forget that you do have these other two data types, which can come in handy for certain projects. So we're going to grab the elevation LiDAR option, and then we are going to zoom in. I'm using the scroll button on my mouse, by the way, but you could double click. You can drag and highlight an area to zoom in. Lots of different ways to do it. We're going to clip some elevation data for a fairly broad area in southwest Baldwin County, specifically kind of looking at developing an elevation data set around Fish River, which is this stream right here. So if we scroll in and look at that, we can confirm somewhere that this is Fish River. There it is. If we were doing this for, say, a model study, we would want to go make sure that we understood where the gauging stations are. So historically, there had been a water level gauge here at US Highway 98. It's no longer operational, but there's still archived data that you can grab for that. And then we might want another gauge somewhere upstream to define the upstream boundary condition. And so if we just wanted to generally look at where that might be, we're going to type in USGS NWIS mapper to go look at the National Water Information System website. And if we do this, we can zoom in. On this one, you can't scroll with the mouse wheel. You have to actually double click or use the zoom tools above. But you'll see that we've got well, there was 1 second ago. There should be a station around here. There it is. So County Road 32, there's a gauging station there. There might be gauges further upstream. There is up here, but I don't think we need to extend the domain that far up. So we are primarily going to look at creating an elevation data set that extends north of County Road 32 down to Mobile Bay. And when you do the selection, it's good to be quite generous about the area you're selecting, because you never know what you're going to end up needing. So it's good to go quite a bit distant from that. And the file that you're going to be working with is not overly complex or large. So I'm going to come in here. I'm actually going to grab a very generous area that is going to be way, way bigger than what we need. But it's nice to be able to have access to all that data. Notice that I'm actually clipping off point clear inadvertently, so I'm going to escape. And I actually don't want that. So unfortunately, it does require me to zoom back in. But again, I'm going to come in here. I'm going to grab a fairly generous area of our watershed. And sometimes you kind of have to do this through trial and error, to get the area that you need for your data. So with that box selected, it's going to go through and query all of the available elevation or LiDAR data sets that it has in its database. And this is just one database. There are other potential sources of elevation data out there. The USGS National Map Viewer is another one. But typically for our uses, NOAA Digital Coast has pretty much everything we need. It won't really have county-specific data, so if Baldwin County has newer LiDAR data, it probably won't pick that up. But it's less important for the purpose of this tutorial. But when it queries the database for things that fall within this box, and that could be fully or partially falling in or overlapping any portion of this box, the data sets, available data sets, will pop up over here on the right. And as you scroll over them, you can see they're shading the areas of coverage. So this, as an example, this 2005 LiDAR data was just along the coast. So it was kind of flight level data that was fairly low, just along the shorelines. But some of these areas have much bigger coverage. One of the things to stay away from is thinking about preparing an elevation data set for running a hydraulic or hydrodynamic model, is that you're going to also need information below the water surface. And around here, LiDAR data does not necessarily penetrate through the water column very effectively because our water is murky or cloudy. So as a result, if you find data sets over here labeled LiDAR, and particularly ones that are labeled LiDAR DEM, they can be quite deceiving because you're going to think that maybe you also like have a complete elevation model, but in fact, you won't actually have the stuff below the water surface. So to make this process as painless as possible, I would recommend scrolling down here to the NOAA NCEI Continuously Updated Digital Elevation Model. This has what is called 9th arcsecond resolution. I believe that is 3 meters resolution. So every 3 meters or about every 10 feet, you're going to have a point of data. Or in this case, we're going to be generating a raster image or a TIFF image. And so that image is going to be made up of a bunch of pixels that are 3 meters by 3 meters squared. So we're going to go ahead and grab this, and we're going to add it to our little shopping cart over here. And if you wanted to download multiple products, you can. You just continue to add them to your shopping cart. So maybe we'll go ahead and do 2, and I'll also demonstrate how to merge these in QGIS to come up with a composite data set. When you selected all the data sets that you want, go ahead and come over here to your shopping cart. And these are going to show you what is in your shopping cart, and you click Next. And now you have to define the parameters of the data set. We are going to work in UTM coordinates. That stands for Universal Transverse Mercator for the models that we're going to be running. UTM is a very reliable, flat, relatively flat projection system that will have length scales in meters. And it will typically identify the appropriate zone, but you do need to check. We are in zone 16 here, so we can confirm that that is correct. Everything else over here is okay. The horizontal datum N80, 83 is appropriate. And then our vertical datum we want is NAVD 88. So that's going to be our elevation datum. And our output format we want as a GeoTIFF. And then we want to make sure that the settings for the other data set match that. So we can do select a similar data set usually, but it doesn't look like it's going to let us do that. So just come through and make the selections needed. We're going to set everything to meters when there is an option to do so. This one on the LiDAR data gives you a little bit more, ask you more questions about how you want the output. So we want it as a raster product. Our grid method is just going to be averaging. There's all sorts of different things. You can click on these for more details. The defaults over here typically are okay. And then the grid size over here is going to be 1 meter. I don't recommend actually using 1 meter to be consistent with the other DEM resolution. I think using 3 meters is just fine. It's unlikely that we would actually run a model with a resolution at 1 meter or below. So typically, 3 meters resolution is going to be enough to pick up most of the hydraulic conveyances that we need to resolve in the model to get something realistic. You could download the 1 meter resolution and just later throw away the stuff that you don't need, but I think for this application, it's unrealistic that we need resolution below 3 meters. So we'll select that or enter that to be consistent with our other data set. There's little check marks over here for LiDAR data sets that you'll typically see to fill in small gaps. And that's important because there can be coverage gaps it's helpful to have the system just average those in. So we're going to click Next. And you're going to make sure you enter your email address and your organization. You don't need to check this box down here. Click Next. It's going to confirm everything here. Usually I like to take a screenshot of this just to have for reference purposes. And I just realized that since I'm doing a screen recording, I can't do that. But I'll have a movie of it to refer back to later. But I usually take a little snapshot of this to remind myself of the settings that I selected for the data sets. For the most part, they actually are also repeated back to you in an email that you will receive. But I like to have this as a backup and click submit. And it'll bundle up your project request and submit it to NOAA Digital Coast. And you will pretty quickly receive a confirmation email acknowledging that you have submitted this request. And depending on the size and complexity of the data set and how much stuff you've ordered, it can take anywhere from 2 minutes to 2 days to get your package data back. 2 days is a little bit of an over-exaggeration, but it can take hours in some cases to get your data bundled up and sent to you. So this isn't necessarily something that happens immediately. So I'm going to try and pause this and then come back and we'll do a part 2, which will be what the heck do you do with it once you get it in your email inbox. So stay tuned shortly for another video.